I'm a professor in computer science here at the University of Colorado, and I'm going to explain you a couple of things about the systems and programming environments that we are creating. We work on a system called AgentSheets, and AgentSheets actually spawns off a couple of different systems. The kind of things that we're doing range from programming environments for end users and kids who can use AgentSheets in a special form to program these kind of things, but also can create their own simulation games. So I'm just going through this quickly here. So the one thing that we're working on with respect to Lego is called Lego Sheets. Lego Sheets actually combines the idea of programming with ideas of simulation and manipulation. Then Simbrick has taken some of the ideas of Lego Sheets and has taken these vehicles and even the worlds in which the vehicles interact in, and we have digitized these things and make actually virtual versions of these things interact on the computer with each other. So we have simulation, vehicles, robots, and environments. Then another line of work is called the Visual Agent Talk Behavior Exchange. This actually allows people to create their own agents and programming bits and pieces and stick them into web pages and create communities of social programming. They create pieces that they can exchange with each other. In WebQuest, we combine the idea of the World Wide Web with interactive simulations. We use these kind of things in schools quite successfully. Essentially, this allows students to build their own works and hooks them up to the World Wide Web. Then finally, we're working on a system called AgentSheets. AgentSheets is actually a system that allows end users who are not programmers to create applications, simulations, and programming environments for themselves on the World Wide Web in Java.
I'm going to show you Lego Sheets, a programming, simulation, and manipulation environment for the Lego programmable brick. The brick, which is a computer in itself, can take input from sensors like these reflectance sensors and control motors like the ones that we have built into this vehicle. Lego Sheets is the environment that we developed for controlling the brick, and it contains a gallery with all the components that you can attach to the brick. So we have motors, we have reflectance sensors, touch sensors, and also some other multimodal cells that we developed, like the microphone that takes advantage of the Macintosh microphone. And then you have the virtual brick, which is the simulation environment. The virtual brick is a depiction of the surface of the brick. It has the sensor ports up here, the motor ports down here, like the brick. So let me go ahead and put a couple of motors in and connect them to the brick. And if I do that, I can now control them directly from the computer. Turn them on, push forward and backwards. I can do the corresponding thing with the sensors. If I wire a couple of reflecting sensors the same position that they are on the brick, I can wire them up and get their values from the actual reflectance sensors on the brick. You can also change representation of the value and have it as a plot over time instead of a number, so that gives children different ways to explore sensor values and motor values. Apart from the traditional Lego components that can be hooked up to the brick, like Lego sensors, we took advantage of the modalities that the Macintosh provides. So we have a cell, a microphone cell, you can put in our world, and if we turn it on, you can see that it picks up the noise level from the Macintosh microphone. And this, you can also change this into a plot mode and watch the level of the sound go up and down as you speak. Hello.
white squares.
Yeah, it must have been.
It is cool. Yeah, 6 to 9. So that was the way it works.
If neither of these are going on at all, then the default is it's just going to go straight for 5.
At a 5 speed.
Yeah. And then over here, we have another motor. And it's the exact opposite. It's the exact opposite. Aw.
So what do you think is going on?
See the arrows? If it goes forward, then this is for the arrow, and it goes.
When Alex and Jim first approached me about using the computer to make drawings, my initial response was to think in terms of how I could make the computer do what I wanted it to do, because I've been working with the computer as a drawing tool on my own in my studio. And it became apparent pretty quickly that that wasn't the way to do it. It wasn't very satisfactory. And so I decided, rather than try to force the computer to do what I wanted it to do, to try to collaborate with it and interact with it as a sort of freely roaming tool in the world. And the drawings that we made most of them are the result of that kind of process. Last week, I got the brick out again and started making drawings. And I made some simple black line figures. The computer, the sensors can respond to various light levels. And so when it sensed the black line, it changed direction according to the program that's been downloaded. So within a triangle, this is the kind of pattern that one program made, drew with a marker attached to it.
What's the program telling it to do when it sees a black line that's supposed to behave in a certain way?
Yeah, it changes direction after a certain period of time with the timer programmed into it as well.
So it's responding to the black line?
So the sensors are, they're just seeing single bits, and they're not, it's not recognizing color.
No, it's not recognizing color, it's just seeing a grayscale essentially. It's a value between 0 and 1.
Try another spot.
Okay, now I'm going to tell you about SimBrick. As you can see on the screen here, I have rule actions and rule conditions, and these are dragged and dropped into rule editors that control the behavior of the SimBrick icon on the screen. I've already dragged and dropped some conditions and actions into the rule editors here and made a small program to make the SimBrick follow the road. I'll show you the way that you drag and drop a condition or an action into the rule editor is by first clicking on it, dragging it until it's accepted by the box that you want it to be accepted by, letting go, and then you can see it's added. And I did that on the side here so you can see it. As well, the map that the Simbric icon is running on is a bitmap that's made from a still picture of a real Lego road. This bitmap can also be generated from a live feed from a video camera. The idea here is that you want to get real-world noise into the virtual environment. And so you want to let people test out their programs in a virtual environment that's not idealized. Again, we've created Simbric in the hopes that people will be able to test out their programs more easily on the assumption that they'll have more computers in the lab than they will Simbrics. And so now, since I've already written the program to make the Simbric follow the road, the way I get the program to run is by applying the rules of the left motor and then applying the rules of the right motor. And as you can see, the Simbric is now following the road and running along the map. We think that this holds a lot of promise for a lot of applications. For example, Ernie Arias in environmental design wants to use this type of program to model the HOP, which is a bus system that runs here in Boulder. And the idea is that you have a virtual environment where people can test their programs that hopefully has real-world noise. And you ought to be able to import a lot of different types of bitmaps into this kind of framework to allow some interesting applications to take place. Thanks.
My name is Karina Perrone, and I'm a researcher at the Center for Lifelong Learning and Design. I worked with a middle school teacher in the Boulder Valley School District who teaches middle school, teaches the internet in his classroom. We watched kids use the internet in the classroom, and what we noticed was that they would get hypertracked or sidetracked from what they were researching and go off onto pages that were unrelated. So we came up with the idea of using an interactive simulation game with the internet so that they had to build and play these games, which would keep them focused on what they were studying. So I'm going to demonstrate WebQuest, and the first thing that we have kids do is play an example game. They choose a character from a palette of characters that we have for them, and they place it on the game board, and then they run the game board. Then, using the cursor keys, they can maneuver around the game board, and they can go up to various objects and try to open doors. And the system will tell them that they have to have a key to open a door, and they don't have anything. And they can see that the keys are hidden underneath the scrolls on the game board, so they can go up to a scroll, pick up a scroll, and the system will tell them that they have a scroll now. And then the page on the web changes, and it tells them it's a scroll, and it asks them a question, and they need to answer the question in order to get the key, which is underneath the scroll. And this question says, what are the 4 largest moons of Jupiter? And then they have to search the web to find the answer. So they go to a solar system site, and they can click on Jupiter. And as they read through the site and get more information on the site about Jupiter's moons, they find the answer to their question. So as soon as they have the answer, they take it back to the game, grab the key, and then type in their answer. Armed with the key, they can now go and open the locked doors. There are other objects on the game board, such as purses of money, which ask them questions, and if they don't know the answers, they can use the web to find the answer. And then the goal of this example game is to unlock the door once they have the key, and then answer the question that is posed by the dragon on the game board. And the question that the dragon poses is made up of either a combination of, or it's on one of the sites that they've already visited. So they have to do a bit of searching to get the right answer. They can also do things like enter castles and sail ships by paying the ferryman. ship and sail to islands, which opens up another level of the game. So once they're finished playing the test game, then we have them pick a subject and research their subject on the web, and they develop questions for their game, and then they're ready to build a new game. And they do this by using the palette of characters that we have already made up for them. So they can lay down forests and lay out a path, and then they can put their keys and scrolls down and program them very easily using AgentSheets and Visual Agent Talk. And we have an interface in the system that will let them type in their questions, and it will build an HTML page for them. So the idea is that the students do all their research on the web, and then they bring that information directly into the game and use it. And so we're working on things to make the grading a lot more robust, so they can write stories or essays, questions, and we're working on things to make it easier for them to build entire simulations related to the themes of what they research rather than related to the existing characters in WebQuest. That's it.
Okay, now I'm going to show you how you can use the agent repository to drag agents from the World Wide Web into your own gallery, or how to add stuff from your own gallery, your own creation, how you can add that into the web catalog. You're going to do it in 2 steps. First step is dragging an agent out of a web page, how that's done. So we got to go into Netscape Navigator, for example, and we drag and drop the fish. We are talking about the fish tank domain here, into the gallery of AgentSheets. And after a couple of seconds, the fish that used to live in the website just a couple of seconds ago now is in my own gallery, and I can use it in AgentSheets. For example, I can put it in my fish tank like I do it right now, and I can run it, and it just behaves as if it has always been here, but in fact we just downloaded it from the web. So now I want to show you the other direction. If I have created a new fish, like in my case a cardinal tetra, and I want to share that artifact with the rest of the world, I have to put it into the web page. And for this purpose I use the Agent Share extension. I go into the File menu, click on Upload Agent, and get the dialog box that asks me for information about the agent I want to submit. It already knows the name, and it has default values for my name, my email address, my homepage, and so on. What I have to type in, though, is the topic, which in this case is fish tank. And also, what you want to do is give in a short description of what the agent does. So in this case, I say the cardinal tetra is a schooling fish. Keep at least 7 in your tank. So after I typed in this short description, I'm basically finished with my submitting process, and I click on the upload button, and within a couple of seconds this agent gets uploaded to the central site, and in about 5 minutes the web page will be updated and my fish will be included in the web page.
My name is Jim Ombach. I'm a researcher in L3D. The project that I'm currently working on is one called Micro AgentSheets. Micro AgentSheets is a subset of AgentSheets actually re-implemented in the Java programming language. Micro AgentSheets has the capability of running AgentSheets simulations in games, but not authoring them. Micro AgentSheets will become a part of a larger project called Instant Java. The purpose of Instant Java is to turn AgentSheets into an authoring environment for simulations that can be run in Micro AgentSheets and distributed over the World Wide Web. The purpose of the Instant Java project is to bring end-user programming to Java users and to allow the creation of cross-platform AgentSheets simulations and games. Micro AgentSheets, again, is a version of AgentSheets re-implemented in Java, which means that you can distribute micro AgentSheets simulations and applications over the World Wide Web. In this one example, I'm showing you a particular simulation that's been created using micro AgentSheets and is being run through Netscape 3.0, a regular web browser. As you can see, micro AgentSheets simulations have many of the same components that you're familiar with in AgentSheets. There's a gallery of agents that you'll use in your simulation. There's a worksheet where you'll build individual simulations. There's tools along the side and simulation controls along the bottom. This one particular simulation is a simple program that allows you to build ice cubes of different shapes and sizes and watch them melt. In this case, there's only one agent in the gallery, and that's the ice agent. And by selecting the proper tool in the tools, I can create ice cubes of different shapes and sizes and then start them melting, and I can compare the rate at which ice cubes of different shapes and sizes melt in comparison to each other. Again, this is just one simple example of the kinds of things that we hope to do using micro AgentSheets and AgentSheets together in the project called Instant Java.